Welcome to Preeminent Test Prep. Today is day 2 of our 90-day SAT preparation series. Today we'll be doing 30 minutes of SAT math work, just teaching you the basic equations and all of the information that you kind of need to know to get a basic understanding of how to be successful on the SAT math section. So we aren't really going to be getting into practice problems, more so understanding the equations and what they mean. And then after that half hour, we'll go ahead and get into the SAT writing section and some of the grammar rules that you'll need to know for that section. So to start, we're going to go ahead and get started with the most important equations that you'll need to know for the SAT math section. So we'll go ahead and get started with the slope-intercept form of a line. So the slope-intercept form of a line can be given as y equals mx plus b, with b being your y-intercept. And keep in mind this should go in your notebook, so make sure you're taking notes on this. So this b is going to be your y-intercept. Now why is that? Well, because if you plug in 0 for x, 0 times whatever the slope is going to be 0, which means that your y-intercept will have to equal b, so b will always be your y-intercept. All right, so y equals mx plus b. So what is the m then? If b is our y-intercept, m will be our slope. So what this means is for every x that we increase by, so for every 1 unit we go to the right, that means that we will go up or down however many units our slope is. So let's say that our slope was equal to 2x, right? Well, then if we increase x by 1, so if x increases by 1, then y will increase by 2. Now, if our slope was negative, say that our slope was equal to negative 7x. Well, then every time our x increases by 1, our y will decrease by 7. So that decrease is by 7. We'll go down 7 or negative 7. So that's the basic understanding of our slope-intercept equation. So another thing that you need to know is how to manipulate it. So let's say that we have y equals mx plus b, and you're asked for what the point 2 and then this y is based on this equation. So let's say our equation is y is equal to, let's say 5, or we'll go 3x plus 7. So what is y when x is 2? Well, y when x is 2, we plug in 2 for x, so we have y is equal to 3 times 2 for x plus 7. That's going to be 3 times 2, that's 6. 6 plus 7 will be 13, and your y will equal 13. Likewise, let's say that we are given y, but not x, so we have to solve for x. We're given that y is, we'll say 18, and we'll say that our equation was y is equal to 15x plus 3. So if y is 18, and that's 18 is equal to our 15x plus 3, and we have to solve for x, we go ahead and subtract 3 from each side. We subtract 3 from each side, we get 15 is equal to 15x. We divide each side by 15, and we'll get that x is equal to 1. All right, divide by 15, we see that x then is going to equal 1. So that's a basic understanding of the slope-intercept equation. So you can go ahead and put down this equation right here in your notes, label that the slope-intercept equation, label that b is going to be your y-intercept at all times, and that m will be your slope at all times. And your equation, your point, is going to be xy. That's going to be your set of points for that equation. So when x is 0, that y will just be your y-intercept. All right, the next equation that you're going to need to know is your vertex form of a quadratic. So we've got now vertex form of a quadratic. All right, so vertex form of a quadratic, the equation for that is going to be y is equal to a, where a is just a variable, times x minus h in parentheses squared, all plus k, where k is going to be your constant, right? So your vertex, now keep in mind that this is a quadratic, so you may be more familiar if it were to say y is equal to ax squared plus bx plus c, and that you might also remember the quadratic formula is based off of that form of quadratic as well, and we'll get into the quadratic formula later in today's lesson. But you can see that this right here, this equation that you're more familiar with more than likely, it's just derived from our equation over here, our vertex form. So in our vertex form, our vertex is given by the point hk, right? So this k here is going to be our minimum if a is positive. So if a is greater than 0, which means if a is positive, then that k value is going to be our minimum. So then k is minimum. Now if a is less than 0, which means a is negative, then that means that we have a downward slanting, or I'm sorry, a downward facing parabola, right? So it's down. That means we're going to have a maximum at k. So then k is a maximum. All right, so then k is a maximum. All right, so if a is positive, our graph is going to look something like this. And if a is negative, our graph will look something like this. And in which case, if a is positive, we have k as our minimum value, and if a is negative, then k is our maximum value. So what point is our x for our vertex? Well, that's going to be h, right? So we have to keep in mind that if h is a positive number, so we'll say that our vertex is at, if our vertex is at, let's say 3 and 10. Well, that means that k is going to equal 10. And that means that our h value will equal 3, right? So we'll have x minus 3. So then what's our equation going to look like? Well, our equation, we don't have a definite a value because all we're given is a vertex. So our equation could look something like y is equal to, we could say that a is 5. We'll say a is 5. And then our vertex then would be x minus 3 because our vertex is at 3. So h is going to be 3 squared. And then plus k, we know k then has to be 10. So what that would look like as a graph, we'd have our x and y axes. We would have positive 10 as our minimum, and we would have that at 3. So we got 3. We'll put 10 right here. And that's going to be our minimum, and we are going to go up. So it's going to look something like this. That would be our parabola for that type of equation. So you're going to want to go ahead and put in vertex form of a quadratic. This is your equation here. Make sure that you mark that your vertex is at hk, because this is another very important equation. You want to be able to recognize immediately where your vertex is going to be from that equation. So an example problem would be, say that y is equal to 10x minus 7 squared plus 17. And you were asked where your vertex is. So where is vertex? Put vertex question mark. You need to be able to identify that since this is a minus sign here and not a plus sign, that your vertex then is going to be that positive 7x, because we do x minus h, with h being the x coordinate of our vertex. So we know then that h is going to be positive 7. And we know that k is always going to be right here, and that's going to be positive 17. Now what if our equation was y is equal to 10x plus 7 squared plus 17? Now in that case, our vertex is going to have a negative x coordinate because it's x minus h. So if it's x plus 7, we must be subtracting a negative 7. So that would be negative 7 and 17 for our vertex. All right. So our next equation that you're going to need to know is the distance formula. So the distance formula. So the distance formula, it's a very long equation, but if you want to simplify it, you can, because there's really two ways to view it. And as long as you understand the gist of it, you'll be okay. So the long form of it is that distance, which we will represent as d, is going to equal the square root of x2 minus x1 squared plus y2 minus y1 squared. Now what that's derived from is the basic a squared plus b squared equals c squared, right? So in this case, our c is going to be our distance, right? And I could go ahead and derive that for you if we really wanted to, but you really just have to know distance is going to be, our distance is going to equal the square root of x squared minus, or I'm sorry, of our second x coordinate minus our first x coordinate squared plus the difference between our two y coordinates squared. So what's another way to write this more simply? That's going to be that d is equivalent to the distance between our x's, right? So that's going to be our run. So the square root of our run squared plus our rise squared, right? Because the difference between our y values is just how much we rise, and the difference between our x values is just how much we run. So if you were given a coordinate plane, let's say we had points at, we'll call this 5, call that 0, call this point, we'll do 4. So let's say we had a point at 0 and 5. So first point's going to be at 0, and 5. Let's say that we have a second point then that is at, we'll go with 4 and 1. So 4 and 1. So let's say we had to find the distance here. Well, what's our run? So we see that we went over 4 because we have 4 as our x2. So we got 4 as our x2. We have our x1 of 0. So it's going to be 4 minus 0 squared, which is going to be 4 squared. And we see we have plus our rise. We see that we go from 5 down to 1. Now keep in mind this value is squared, so it doesn't matter which way you look at it. It's a difference of 4. So we can go ahead and do plus 4 squared. So we'll do that, and that was from 5 minus 1. So I'll go ahead and put that down as well. We have 5 minus 1 squared, right, which is just going to be plus 4 squared. So we see that that's going to equal the square root of 32 because 4 squared is 16. 16 plus 16 is going to give us the square root of 32. So that'll be our distance between those 2 points. And you can see you could look at it either way. You could use that full formula, that x2 minus x1 squared plus y2 minus y1 squared, or you can look at it as your run squared plus your rise squared because you ran from 0 to 4, so that's a difference of 4, and you dropped or you rose from 5 to 1 or 1 to 5, which is also a difference of 4. So we see our distance then is going to be the square root of 32. So you can write down, I would recommend writing down both this equation right here, your full distance formula, as well as the simplified version of your run squared plus your rise squared beneath that square root. So that's the third equation that you're definitely going to need to know for the SAT math section. So your fourth equation that you're going to need to know is the quadratic formula. It's not necessarily super often that you have to use it. A lot of times you can factor things on your own in your head if you can see the pattern, which I'm going to try to teach you to do in later lessons to see the pattern so you don't have to use this formula because it's very long and drawn out. But you do still need to know it because it's quite possible that there could be a question where you can't really factor it and you're going to have to know the quadratic formula. So like I said before, quadratic formula, it's when the equation is y equals ax squared plus bx plus c, right? And that can also be derived from that vertex form when you multiply everything out. So the quadratic formula is not this right here. So I'll go ahead and write that so you're not confused. This is not the quadratic formula. That is just the equation that it's based on, right? So you'll have an equation like this, and your quadratic formula is going to solve for your roots, right? So your zeros. So that's going to be where that line from your quadratic formula crosses that x-intercept. So it's going to find your x-intercepts for you. So that's going to be where y equals 0 is what it's going to find. So your formula then is going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now what you can see is that these letters right here, these b's, these a's, and these c's, they line up to this equation up here, right? Your y equals ax squared plus bx plus c. So if you need to use the quadratic formula to solve for a question and you're given your formula in vertex form, then you're going to have to multiply it out, right? So you're going to have to do this x minus h squared. You're going to have to multiply it by a, add the k, in order to get it in this form over here. So that way you can use the quadratic formula, right? All right. So let's go ahead and get into a practice question. So you see you have your quadratic formula right here. Go ahead and label that QF, quadratic formula. So let's go ahead and get into an equation. So let's say that we were given the equation y is equal to, let me pull it up real quick. Let's say we're given the equation y is equal to 4x squared. So we got 4x squared minus 5x plus 1 is equal to 0. So now let's say we have to use our quadratic formula. So let's go ahead and look at it. And keep in mind, you're going to want to memorize this quadratic formula before you take the SAT, so you have it in your head. So you're going to have x is equal to negative b. So let's go ahead and identify our a's, b's, and c's. We see our c is going to be our 1. We see that our b is going to be our negative 5. B is negative 5. And we see that our a is going to be 4. So we've got a is equal to 4. So we're going to use our quadratic equation to solve for our roots, right? Our zeros. That's where our x-intercepts are, where y equals 0. So we're going to go ahead and plug in our numbers. So we got negative b. We see b is negative 5, so we have negative 5, which will be a positive 5, and we'll simplify that later on. Next we have plus or minus the square root, b squared. We see that b is negative 5, so we'll have negative 5 squared. And then we have minus 4 times a times c. We saw that a is 4, so we have minus 4 times 4, and then times c. We see that c is 1. Keep in mind that this is all over 2a. It would not surprise me if one of the answer choices on the SAT was the x equals and then all of what's up top, but you forgot to divide by 2a. You have to remember to divide by 2a. We see a is 4, so we'll be dividing by 2 times 4, which will equal a. Or, I'm sorry, which will equal 8. Right, 2 times 4, that's going to give us 8. So now we can go ahead and simplify. So we're going to have x equals positive 5 plus or minus the square root. We have negative 5 squared, which is the same as 5 squared, because negative 5 times negative 5 will give us a positive 25. So we have root 25. Now we have minus 4 times 1. 4 times 1 is just 4. So we have minus 4 times 4, which is minus 16. Now that's all over 2 times 4, which is 8. So we can go ahead and keep simplifying now. We have 5 plus or minus the root 25 minus 16. That's going to be square root of 9. Now what do we know about the square root of 9? We know that the square root of 9 is 3, because 3 times 3 is equal to 9. So now we have 5 plus or minus 3 all over 8. So to find for our zeros, we have to go ahead and do x equals 5 plus 3 over 8, and also x equals 5 minus 3 over 8. Now when we do that, what we're going to find is we're going to find that we have our 5 plus 3 over 8. 5 plus 3 is 8. 8 over 8 is 1. So we see that one of our zeros is going to be 1. So one of our roots will be 1. And then over here we have 5 minus 3, which is 2. 2 over 8 is going to give us 1 over 4. So 1 over 4 is going to be our other root. So we'll have root as 1/4, and we also have one of our roots be 1. So we have x equals 1 and x equals 1/4 as our roots there. All right, so the fourth equation that you're going to need to know for the SAT math section was the quadratic formula. So I'm sorry, our fifth equation is going to be multiplying exponents. So we have multiplying exponents. So I'm going to put a break in between these because now we're kind of switching topics. So our next couple equations are going to deal with exponents, right? So we've got switching from quadratics and parabolas now to exponents. All right, so multiplying exponents. So if you have the same base, let's say that our base is, we'll do z, right? We'll say z is our base, and we will say that x is our exponent, right? So we have z raised to the x power. Let's say we have that multiplied by z raised to the y power. Now let's say that we were asked for what z is to the what power, right? So let's say that this is, we'll pick q, right? So we have to solve for q. And let's say that we are given that x is equal to 15 and y is equal to 9, right? Well, what's unique about exponents is that what we can do is we can just add our two exponents. So if we take, only if we have the same base though. Keep in mind, this is only if we have the same base. So I'm going to put that right here. This is important. You should add it to your notes. We can add exponents when we are multiplying together. And they have the same base. They have to have the same base. Because these two have the same base of z, we can add x and y to get q. So what that is going to equal then is we're going to have z, x plus y will equal q. We see that our x and y, we see x is 15, we see that y is 9. So now we have z raised to the 15 plus 9. We know 15 plus 9 is equal to 24, so we'll have z to the 24th. So that's an example of multiplying your exponents, right? So if we have the same base, we're asked to multiply them, we are going to add their exponents to find what our answer will be, right? So another thing with exponents would be if you have the same base and you are dividing them. So let's say we have exponents that are being divided. So let's go ahead and use z again. Let's say we have z to the x once again, and we have that over z to the y. And let's say once again we are asked for z to the q. We'll say that x is 17. We will say that y is 13. So what we're going to do is we are going to subtract now. We have the same base, right? So once again, we got same base, which is important. You can only use this rule if you have the same base, which means that we can go ahead and subtract. So what we're going to do is we're going to take z raised to the x, and we're going to subtract the y, right? And that is going to give us z to the q. So right here, we could rewrite this. We have z to the x. We know x is the 17th power, and we have that all over z. Keep in mind, z can be any number as long as it's the same, right? So z could be 3, so we would have 3 to the 17th power over 3 to the 13th power, and this rule would apply. As long as z is the same, we are okay. We can use this rule to go ahead and apply it. So we're going to have z to the 17th over z to the 13th. Then we know that z to the power of q, we know that that q then is going to equal 4 because we subtract that 13 from 17. So this is going to equal z to the 17 minus 13, and that's going to equal z to the 4th. All right, so there's your equation for dividing exponents, right? So what you're going to want to write down in your notes for that is going to be z to the x over z to the y is going to equal z to the x minus y. So that would be the equation you want to put down in your notes. Make sure that you have that in your notes because that's an important equation to know for the SAT math section. All right, so your next important equation is also going to deal with exponents. And this is when you have an exponent that is raised to a power. So let's say we'll use z once again, just for transparency and consistency. Let's say that we have z raised to the power of x, right? And now we're going to take whatever that number is, which is why we're putting it in parentheses. And let's say we're going to raise it to the y power. Well, now we are not going to add x and y, but what we're going to do is we're going to multiply them. So we're going to take z, and its power is going to be that x times that y. So now we have x times y. So this is the equation that you need to put in your notes. Is going to be if we have z raised to the x in parentheses, and then raised to the y. So we're taking a power and raising it to another power. That means we have to multiply those powers together. So if we had, we'll say x is equal to 13, we'll say y is equal to, let's do an easy number here, let's say 3. So now we are going to go ahead and take z. We see that we have it raised to the 13th power. And we are going to go ahead and raise that then to the 3rd power. So we can go ahead and rewrite that then as z to the 13th times 3. 13 times 3 is going to give us 39. So we will have z raised to the 39th power is how that would simplify out. All right. So moving on, we are done with exponents at that point. So we can go ahead and put a line through that. So now what we're going to do is we're going to start looking at some patterns. So these are going to be patterns with expressions, right? So you're going to have sets of variables with x and y, and you're going to have to be able to identify patterns to factor them. So let's say that we have x squared minus y squared. So when you see x squared minus y squared, you need to recognize that that is the difference of perfect squares. So I'm going to go ahead and put that right here. The difference of perfect squares. Difference of perfect squares. So what that means is if we have x squared minus y squared, keep in mind x and y aren't important. It could say z squared minus q squared. It doesn't matter what the variable is. They're just variables, just letters that signify that it can represent any number that can be input for it. So if we have x squared minus y squared, we have to recognize then that that could be factored to equal x minus y multiplied then by x plus y. Because when we do this, I'll go ahead and show you. We use FOIL. We do that x times that x, and we get x squared. Then we're going to do this x times this positive y. Right, so that's going to give us plus xy. Now we take this minus y times x. Now we have minus xy. And then we take that minus y and multiply it by y, and we get minus y squared. So this plus xy right here and this minus xy are going to cancel to give us 0. And we would be left with our x squared minus y squared. So we got x squared minus y squared. So we see that the equation we need to remember then for our difference of perfect squares is going to be x squared minus y squared is equal to x minus y times x plus y. So keep in mind that's a pattern that you're going to want to recognize. You're going to want to be able to remember that for the SAT. So I want you to memorize this equation before you take the SAT. If you can memorize this equation, then when you see something like this x squared minus y squared, you'll be able to factor it a lot faster because you know that those middle terms will cancel and you'll be left with that x squared minus y squared. So you'll see an equation like this. Say it'll be, go ahead and put one down. We'll just go ahead and use numbers, right? Let's say that we have a 6 for x, and then let's say that we have a minus, we'll say y is 2, and then we'll say multiplying by 6, and then we've got a, so we said y is 2 over here, so we're going to have a 6 plus 2 over here. So now what are we going to do? We're going to ignore our middle terms. We're going to go ahead and do x squared minus y squared. So our x squared is going to give us 36, and then we're going to have minus y squared, which would be minus 4, and we know that that will equal out to 32. So 32 would be our answer there, right? And by doing that, we don't have to worry about doing this negative 2 times this 6 and then doing our 2 times our negative 2, right? Okay, now we can go ahead and move on. We've got our next equation. Next equation is another perfect squares. So this one's going to be our perfect squares trinomial, right? So this is going to be positive. So in this one, our middle term will not cancel. Our middle term will be multiplied by 2, and I'll go ahead and show you what I mean by that. Let's say that we have x plus y, and let's say that it's squared. So we got x plus y squared. We're setting that equal then. When we go ahead and factor this all out, and I'll go ahead and show you. So we take this x plus y, multiply it by x plus y. We use FOIL, which means we're going to do x times our x, and then our x times our y. We see that we will get x squared plus, because we have x times x squared, plus xy. And then we're going to have our y times our x. So we're going to once again have plus xy, and then our y times our y, right? So plus y squared. So we see that what we're going to end with then is x squared plus 2xy plus y squared. So why is this important to know? Well, if you can memorize that x plus y squared equals x squared plus 2xy plus y squared, you will be able to answer questions much faster because you'll recognize the pattern and you won't have to go through all of this process. You'll just be able to plug in your numbers instead of factoring and then plugging in your numbers with all of this. See how much longer this is versus if you didn't have to do this factorization right here. You didn't have to FOIL it. You just recognized x plus y squared. I can go ahead and plug in my variables in here, right? So the SAT math section, a lot of it's about saving time, right? So you see this, you see how long that is. We want to go ahead and when we immediately see this or this, we need to recognize that we can go both ways with this equation. So we want to have that equation memorized. So I'm going to go ahead and circle that equation and star it so you know that is the equation that you need to memorize right here. This one right here, write it in your notes. I'm going to star it and write memorize. All right, and that's going to take us to our second binomial product rule. So this one is going to be one with subtraction as our middle term. So this would be if we had our x minus our y squared. So this is essentially just flipping the sign of what we had up top right here in this equation, right? So now going down, this is going to be our negative perfect squares. This is going to be negative perfect squares. So when we see this, it's basically just flipping the sign of our middle term, right? So now instead of that plus 2xy, we're going to have minus 2xy. So if I was going to go ahead and factor all of this out, we would have x minus y times x minus y. I'd use FOIL, right? It's going to take me much longer than if I just memorize the equation. We see I have x squared minus xy. Right here, I have another minus xy. And then right here, I have a plus y squared because negative y times negative y gives me positive y squared. I go ahead and simplify that, and I see that I end with x squared minus 2xy plus y squared. Now look at how many steps that took me. If we're doing a math no calculator section and I need to find an answer quickly because I only have about 1 minute per question, I don't want to spend all of that time showing all of this work. What I want to be able to do is see x minus y squared and recognize that that is going to equal x squared minus 2xy plus y squared. because we have to be able to manage time on the SAT math section. We want to memorize these sorts of equations, patterns, and setups so we don't have to waste time on them. So this is the equation. The other equation I want you to put in your notes and memorize. Right? Now, once you have these in your notes, just make sure you take the time every couple of days or tonight, whenever you watch it, go back through after the lesson and just look over the equations. Just try to start to see the pattern, start to recognize it, and just kind of begin to learn it. You'll be able to memorize it a lot more when we go through practice problems in the next couple of weeks, because the practice problems will really start to put it in your brain. But go ahead and start to memorize that equation, put it in your notes, and that'll take us through our last equation for today. We'll save the rest for tomorrow. We'll go through some more equations. We'll go ahead and do it. We'll do a short review of all the equations I put in here just to start to get it memorized in your head, and we'll make sure that you are all set with those before we move on. So now we're going to go ahead and get into the writing section. Alright, so now we can go ahead and get to the SAT writing section. So this will also be about 30 minutes because the math section was 30 minutes, totaling 1 hour total of SAT prep for the day. So what we're going to get into for the SAT writing section is grammar rules. So like I said, the first couple weeks are just going to be kind of teaching you the material so that you're confident in your understanding, and then at about week 5 or 6, that's the point where we start getting into pacing. So right now we're just going to make sure that you know everything that you need to know as far as grammar rules. So over the next couple days, it's going to be a lot of teaching and not a ton of practice problems. But then as we get into the next couple of weeks, that's when you're going to start seeing practice problems, working on pacing, and making sure that you're really fine-tuned for the SAT. But step 1 is making sure that you know the material, because it's all good to pace, but if you don't know what you're doing, you're not going to be accurate. So we're going to work on building accuracy first. So grammar rules. We're going to go ahead and start with agreement and number between subjects and verbs. So we've got agreement and number between subjects and verbs. So what does this mean? Well, the number of a verb has to match the number of its subject. So let's say that we have a singular subject, right? So let's say we have Joseph. Joseph is our subject in this sentence. The sentence is Joseph jumps up into the air. Well, Joseph is singular. That means we have to have a singular verb. So our verb is jump, right? Well, it has to be jumps. Why? Because jumps is the singular form of jump, right? So we have Joseph jumps up into the air. If we said Joseph jump up into the air, we'd be using the plural form of the verb with a singular subject, and that is not allowed. That is grammatically incorrect. Now, if we wanted to use the plural form of jump, which is just jump, then we would have to have a plural subject, right? So we see here, we have plural subject, Joe and John. That's 2, that means it's plural. So we have Joe and John jump up into the air, right? We have jump as our plural subject. So one thing to note about about verbs, right? Verbs with their numbers. So I'll go ahead and switch to my pen here. So we've got verbs, numbers, right? Keep in mind, this should be going in your notebook. You don't necessarily have to write down all your examples, but I would recommend writing down your subjects and your verbs in these examples so you can see how we match the number between them. So verbs, numbers, right? Let's say that we have a couple of verbs. Let's say another example would be he runs, right? We have to add this S. So with a lot of verbs, you're going to have to add that S when it's singular, right? We have he runs, but if we were using it plural, we drop that S. So we have they run. So keep in mind that with a lot of verbs, adding that S on will indicate that it's a singular verb, and dropping that S will indicate that you're using a plural verb. So that's one example, and then one thing to keep in mind. So I'm actually going to write out that for you, and I would recommend putting that in your notes. So that's going to be, if there is an S at the end of the verb, and say that S can be dropped, right? That S isn't part of that base word, right? So that S can be added on or dropped and it's still a word. If there's an S at the end of the verb that can be dropped without, go ahead and rewrite that. That can be dropped without messing up the base word. So if there's an S at the end of the verb that can be dropped without messing up the base word, then it is likely singular. All right, and that's going to be most of the time. Then it is likely singular. Now, if there is no S at the end of the verb, like in they run or jump, then it's likely a plural verb. So that's one thing to keep in mind. So I would go ahead and recommend putting this right here in your notes, that if there's an S at the end of the verb and that S can be dropped without messing up the base word, like jump, jump is your base word, then it's likely singular, right? So Joseph jumps, that jumps is going to be a singular verb, but jump, when it loses that S, becomes that plural verb. So I would recommend writing that down in your notes. All right, so now we've got another example. So we've got singular. The manager writes a letter, right? So once again, we see we have a singular subject in manager. Manager is our subject. There's only one that is singular. And we see we have writes, right? So we have that S added on. So that S added on means that we have a singular verb to match our singular subject. Now, if we have multiple managers, so we're using plural now. So we've got the managers. We have more than one managers. The managers write a letter. So we drop that S, and we have now a plural verb. So we're matching that plural subject to that plural verb. Now keep in mind, subjects and verbs could be more spaced out. You could have a prepositional phrase between your subject and your verb, in which case you have to make sure you have the correct subject, and you still have to match those numbers. So you always want to make sure you're matching your numbers between your verb and your subject. That's very important, so make sure you have that down in your notes. So make sure you write agreement and number between subjects and verbs. Make sure that you write the number of a verb must match the number of its subjects. Put down probably at least one example, and then I would recommend, like I said, writing down this statement right there. So assuming you have all of that, we can go ahead and move on. So we've got watch for collective nouns, right? So this is an important thing you need to know as well. So I would write this down as well. Collective nouns. So what are collective nouns? Well, collective nouns, they're used to group a collection of individuals, right? So a collection of people or a collection of singular subjects, right? So that could be animals, it could be something else, right? So you have into one singular subject. So some examples would be Congress, right? Congress is a collective noun. Why? Because it's collecting that group of individuals that are in the Senate and House of Representatives. It's collecting all of them into that singular subject, Congress, right? So an example that would be incorrect use of a collective noun, right, would be Congress are going to dismiss. Now, why is this incorrect? Well, it's incorrect because we're using a plural verb. And remember, we have to match our number, like I said up here. We have to match, switch to a pen. We have to match the number of a verb with its subject. Congress right here, that's singular. This are here is plural. So what does that mean? That means it's incorrect. Now, if we were going to correct that, we would write Congress is going to dismiss, right? So that's going to be singular subject with a singular verb. We have to match the number of our subjects and our verbs. So how do we know? One thing that you can use to check if a verb is plural or singular is simplify it, right? So Congress, that could be a little bit of a difficult word. Let's say we're using our generic words, right? Would be they for plural and he for singular. So if you're ever stuck, one thing that you can do is just revert to they or he. Just think if I was going to say they and then going to dismiss, what verb would I put in between them, right? So what we would say is we would say they are going to dismiss. So that tells me that are is a plural verb. Now if I was going to say he and then have a verb and have going to dismiss, I would say he is going to dismiss, right? That's going to be singular. All right, so we want to make sure that we're paying attention to our verbs and our subjects, making sure that they are matching in number. All right, don't let prepositional phrases fool you. So this is very important. On the SAT, they will include prepositional phrases after your subject. Now what that can do is that can throw you off when matching your subject and your verb in number, right? You want to make sure if they're singular, that they're both singular. If the subject's plural, you want to make sure that your verb is plural as well. So prepositional phrases. Let's start with what are prepositional phrases. Prepositional phrases are phrases that modify a subject. They include a preposition and an object. So what's a preposition, right? So a preposition would be something like of, something like with, right? Anything like that, that kind of adds on to your subject, right? So you have the band of clarinet players. That's going to be your prepositional phrase. You have the group with the most basketball players. That's your prepositional phrase, kind of modifying that right there, right? So those are going to be your prepositional phrases. We've identified those. So now let's go ahead and identify our subjects in these two examples. Keep in mind both these examples are correct, right? So let's go ahead and identify our subjects. So our subject here is going to be band, and I'll go ahead and highlight our subjects. So we'll highlight our subject is the band, the prepositional phrases of clarinet players. Now what we need to know is when we're matching our subject to our verb and number, we need to ignore our prepositional phrase. So what that means is we can actually go ahead and X it out because we don't want to consider it because it has nothing to do with matching the number of our subject to the number of our verb. So we want to get rid of that prepositional phrase of clarinet players and with the most basketball players. So we get rid of those. Now let's go ahead and identify our subjects. We have the band. Keep in mind that what are these two? What is band and group? Let's think about that for a minute. The band. How many people are in a band? It's plural, right? But what's the thing about it? It's a collective noun. We need to remember back here to our collective nouns. They're grouping that collection of individuals, those clarinet players. It's grouping all of those into the band into one singular subject, right? That band is now a singular subject. So now we need to look for a singular verb. We see we have is, right? The band is. That's a singular verb matched to our singular subject. So that is a correct example of how we would determine if we're matching our subject to our verb if we have our prepositional phrase in between it, right? We get rid of the prepositional phrase and we make sure that we ignore it. In incorrect interpretation, if you were looking at this sentence, what a lot of people would do, they would see of clarinet players, say, oh, players is plural, and then they would use the plural are, right? They would say, switch to my pen real quick, see if I can get it. All right, they would say are very loud because that's a plural form, and they would see this players right here, and they would say, oh, players is next to this verb, it must be players are. But this is of clarinet players, that's a prepositional phrase, which means that we are going to ignore it, go back to our subject, which is band, which is a collective noun that is singular, which means that since band is singular, we need to use is because is also singular. So we need to be matching our number. All right, so let's go ahead and look at our next example. We have the group with the most basketball players is going to win. So once again, if you weren't getting rid of your prepositional phrase, you would see players and assume, oh, players, that's plural. We need to use plural are. But with the most basketball players is a prepositional phrase, right? That's not our subject. Our subject is the group. So we need to revert back here to our subject. Our subject is the group, which is singular. That means we have to have a singular verb, which is is. Is the singular verb. Let's say we weren't sure if are or is the singular verb. What would we do? Well, once again, we would think back to they and he, right? We know that they is plural. If we were going to say they and then going to win, we would say they are going to win, right? So we would recognize then that are is plural. And we would say, if we're going to say he is going to win, you already heard me say it, right? We're going to say he is going to win. We're not going to say he are going to win. We would say he is going to win. So once again, we would see that is singular and are is plural. So when stuck on if a verb is singular or plural, go ahead and revert back to the they and he way to check it. All right, so moving on. So now we've got pronouns, right? So pronouns, they replace these proper nouns, right? So let's say we had, let's use John is a runner, right? John is a runner. And that's terrible handwriting, but that's okay. We'll say John is a runner and he, right? So now this he is replacing John, that he is our pronoun. So examples of pronouns would be he, she, they, that, and those. Those are examples of pronouns. So go ahead and write pronouns in your notes, and then we'll get into the rules with pronouns. All right, so the rules for pronouns. Number one rule, it has to be clear who or what the pronoun is referring to. So we see in our sentence over here, we have John is a runner and he. We know he has to be John. Now, if we were to have a sentence that said something like this down here, where I'm highlighting, Jason and John run every day, and then we were to say and he, we couldn't say and he because we have Jason and John, right? And Jason and John is two people, so we wouldn't be certain of who he is. So that would be an example of making a mistake and not being clear about who or what the pronoun is referring to. So if we're going to use a pronoun, we need to make sure we know who it's referring to. The second rule of pronouns is that the number of the pronoun has to agree with its subject, right? So we can't say John is a runner and they because they is plural and John is singular. That would be a problem, right? We need to have this singular John match with a singular pronoun like he, right? We could have Alyssa is a runner and she, right? We have to match those singular to the singular. If we had, let's say we had John and Jason, once again, are runners, and they, right? That would be correct because we're matching plural to plural. So we want to make sure that we're matching our numbers of our pronouns, right? So our pronoun must agree with its subject in number, and it has to be clear who we're referring to. So let's go ahead and get into some examples, right? So like I said, we got John is a fast runner. So John then is our subject. And then we have a semicolon. So splitting our two independent clauses, we have he goes on a long run every Sunday. That is correct because we have singular he, singular John, and it's clear that the pronoun's referring to John because there's no one else involved in that sentence. Next, we have Jason and John, so we have two people. Run every day, so we have a plural subject. And then we have and they, so they is our pronoun. They is plural. Jason and John is plural. We know that they is referring to Jason and John. There are no other groups of people in that sentence. So we know that we are obeying both our rules, that it has to be clear who we're referring to, and that it must agree with its subject in number. So we know that that sentence is also correct. So what would be an incorrect example? Like I said, an incorrect example would be Jason and Joe, so where you have plural, two people, run every day, and he, well, now we're not agreeing in number, and we're not being specific about who we're referring to. Who is he? Is it Jason or Joe? We don't know, so we're breaking rule number one, and then we're also, therefore, breaking number two in that our number of our pronoun doesn't agree with its subject because we have two people in our subject, which is plural, and we have a singular, our singular pronoun right there. So what's wrong with this? It's unclear who it's being referred to. We don't know if it's Jason or Joe. It just says he. All right, so now we can go ahead and I'm going to give you an example of pronoun use that is not people but objects and show you an incorrect example. So we've got, this is an incorrect example, keep in mind. We have the computers. So the computers is our subject. So we've got subject, computers. I'm actually going to go ahead and highlight other parts as well, and then I'll go back and write it. So we have the computers of students in Poland. Of students in Poland are newer than that. That is our pronoun. Of students in New York, right? So of students in New York. So I'm going to go through and I'm going to mark it up and I'm going to show you what I see. So I see I have computers is my subject, right? So that's my subject. It's plural subject. So this of students in Poland. Some of you may have thought students is your subject. Well, here's why it's not. We have of students in Poland. Let's think back to what we learned before. What did we learn? We learned that we ignore prepositional phrases when determining number with subjects, verbs. We do the same thing with subjects and pronouns. We ignore our prepositional phrases. So we're going to ignore this prepositional phrase. So I'm going to put PR for prepositional and then phrase. So PRP, prepositional phrase. We're going to ignore that. So we actually cross that out. We ignore that part of the sentence when identifying our pronouns and its subject that it's referring back to. So we have the computers are newer than that. What is that? That is a singular pronoun. So here we have a singular pronoun referring back to a plural subject. Right? So we have a plural noun in computers. And we have a singular pronoun. So that is an error, right? So what's wrong? The number is incorrect. We have singular pronoun referring to a plural noun. Remember, we ignore our prepositional phrases for pronouns as well when we are determining number for pronouns. So we're going to ignore those prepositional phrases. Keep that in mind. It's very important for the SAT writing section. All right, so what would be a correct example? Well, if we're going to fix that sentence, we have the computers, computers being plural. Once again, we ignore our prepositional phrase. Are newer than those, right? Those would be the plural form when we're talking about objects. All right, so now we have plural computers and plural those of students in New York. Once again, prepositional phrase, we don't really have to consider it. So that would be how we would fix that sentence. All right, so now we've got types of sentences. So now we're going to get into some types of sentences because you have to be able to know what a comma splice is right down here. You have to be able to know what a run-on sentence is. You have to be able to identify sentence fragments. In order to do that, you have to know what types of sentences are and what constitutes an independent clause. So let's get into some types of sentences. We've got simple sentences. They contain one subject and one verb. Right? One subject, one verb. An example would be the dog, dog being our subject, and then verb being swam, and then he swam to shore. We've got subject, we got verb. All right, a compound sentence, that's going to contain two subjects and two verbs. So we see we have a subject, the man, and we have a subject, he, right? That pronoun he is going to be our subject. We see we have a verb, ran, and we see we have a verb ate. Now what else do we see? We see we have a comma followed by a coordinating conjunction in and. So for a compound sentence, we can connect it in two ways. We can connect it with a comma and a fanboy, right? Now if you don't know what fanboys are, what they are is they're coordinating conjunctions, right? So they're called coordinating conjunctions. And the reason I said fanboys is because there are 7 of them. They are for, they are and, they are nor, they are but, they are or, they are yet, and they are so. Right? So if you don't know the fanboys, go ahead and write those down. The F is going to be for, the A is for and, the N is for nor, the B is for but, the O is for or, the Y is for yet, and the S is for so. So go ahead and write those down if you don't know them, or even just for practice. You need a comma and then one of those 7 words to connect 2 independent clauses, right? An independent clause is basically the same thing as a simple sentence. It's one subject and one verb. So go ahead and write that down. That is number 1 as far as how you can connect 2 subjects and 2 verbs, right? 2 independent clauses together. You can connect them in a compound sentence using that, or option number 2 is a semicolon. So if you're going to use a semicolon, you do not have to use a fanboy. You can just use that semicolon. So if I was going to use a semicolon, I would say the man ran home, and then put a semicolon right here, and then have get rid of my and have the man ran home, semicolon, he ate a meal. So that's how I would adapt that if I were to use a semicolon instead of a comma and a coordinating conjunction. All right, compound complex sentences. So compound complex sentences, they contain 2 independent clauses, right? So similar to a compound sentence, but they also have 1 dependent clause. Now a dependent clause can't be a sentence on its own, okay? So you can't have a dependent clause that can be a sentence on its own. So I'll go ahead and show you in an example before we come back to these subordinating conjunctions. So an example would be the woman ate her breakfast. So we see that that's 1 independent clause or 1 simple sentence. Then we have a comma followed by and, right? We have a comma and, so now we're doing that compound sentence part of it. The man ate his lunch. That's our other independent clause. When he was on break. That is our dependent clause. Now, why is that our dependent clause? Because that can't be a sentence on its own because it'd be a sentence fragment, right? If I was to say, when he was on break, you would say he did what? Because we don't know. It's not a full sentence. It's not a full idea. It's a fragmented idea. It's a dependent clause. It depends on the rest of this sentence for its meaning. So it's depending on that other part of that sentence, right? And the other way you can identify this is this when. So this when, that is a subordinating conjunction. So subordinating conjunctions include the following words, and they tend to start dependent clauses, right? So if you see one of these words, it is likely that it is starting a dependent clause. Now a dependent clause, it can also go at the beginning of a sentence. So if when he was on break was at the start of the sentence, right? So when he was on break, I'm just going to put when ... Just know I'm referring to when he was on break. Don't actually put ... right? That's just indicating the rest of the words. I would have a comma after that if I was going to start a sentence with that dependent clause. I would have to have a comma after it. All right, so subordinating conjunctions include the following words. Don't feel like you have to write all of these out, but I would read over them as I'm going to do now. We have after, although, as, because, before, even if, even though, if, in order to, once, provided that, rather than, since, so that, than, that, though, unless, until, when, whenever, where, whereas, wherever, whether, well, and why. So those are some subordinating conjunctions. Don't feel like you have to memorize them all. Just have a general idea of what they look like. All right, so comma splices. Comma splices, this is an often used question on the SAT and SAT practice tests. So what they should be is they should be easy points for you because it's all about identifying subjects and verbs and making sure that they are connected in a correct way. So the reason I showed you those sentence types up here is so that you can recognize comma splices. Because if you can recognize comma splices on the SAT writing section, it should help you improve your score because there tend to be a fair amount of questions on them because a lot of students make mistakes on it. So it's common for them to show up on the SAT. A comma splice is splitting up 2 independent clauses, right? So 2 clauses that could stand on their own as simple sentences, and you're connecting them with only a comma and no coordinating conjunction. That's the key part there. you're only connecting them with a comma and not a fanboy, right? So I'll put that right there. There is no fanboy there, right? No fanboys. So that's how you can recognize it's a comma splice and not a compound sentence. So some examples. Keep in mind these are examples of comma splices, so these are not grammatically correct sentences. These would be errors, right? So the example would be, the man is very fast, comma, the woman is the fastest hurdler in America. What's the problem? The man is very fast, that's one independent clause, and the woman is the fastest hurler in America is another independent clause. They're connected by a comma with no coordinating conjunction, right? No fanboys. So that would be an example of a comma splice. If we were going to fix that, we would have to add, the man is very fast, comma, and the woman is the fastest hurdler in America, or one of the other fanboys, or we could put a semicolon there if we were going to fix it. So go ahead and get rid of that. All right, so keep in mind that that's an incorrect example, right? That would be a comma splice. All right, next we have, the dog is very small, comma, the cat is the same size as the dog. Once again, we have an independent clause, the dog is very small. That could stand alone as a sentence. We have another independent clause, the cat is the same size as the dog. That's another independent clause that could stand alone as a sentence. So once again, we see we have a comma, and we have no coordinated conjunction, which means we have none of the fanboys. So if we're going to fix this, we could do a semicolon, or we could do a comma in one of the fanboys. That would be how we would fix that. So those are comma splices. So now we can go ahead and get into some examples of run-on sentences, right? So we have, the man ate his food and he went to the doctor. So what's the problem with this? Well, the problem is we don't have a comma after food because we have an independent clause, the man ate his food, and an independent clause, he went to the doctor. So if we're going to fix this run-on sentence, we would have to put a comma after ate his food, or we could get or we could get rid of and put a semicolon there. So either of those options would be correct. So another run-on sentence would be, the woman ran to the store. She enjoyed her shopping trip. So if we're going to fix this sentence, the easiest way to do it would be to put a semicolon after store, because we have a subject, woman, verb ran, and then to the store, which I believe is a prepositional phrase. But either way, that completes one independent clause. And our second independent clause is, she enjoyed her shopping trip, with she being our subject and enjoyed being our verb. All right, so examples of sentence fragments. So like I was saying, sentence fragments, they can't be their own sentences. They're not full independent clauses. They're not full thoughts. They're not full ideas, right? If you're going to have a sentence that can stand on its own, it has to be a full thought and a full idea. You have to be able to take meaning from that sentence. So an example of a sentence fragment would be, the crispiness of the apple, or the crispiness from the apple, right? We see we have the crispiness from the apple, but so what, right? There's no driving message behind it. There's no verb, right? We just have the crispiness from the apple, no verb involved. That's not a full sentence on its own. We have his shoes from the store. Once again, no verb. We just have prepositional phrase, right? And you could have a verb and still have a sentence fragment, right? So if you had something like, Jim running, we say, or not running, let's say we had Jim thought from, I can't come up with a good example right now, but you're just going to have to trust me on that. There are sentence fragments, and it's kind of tough to come up with them because they are kind of rare where they're going to have a verb and a subject and still be a sentence fragment. It can happen. Basically, the rule of thumb would be to check if it's a full idea. So if it can stand alone as a sentence and it can get its point across, then it's not a sentence fragment. But if it cannot stand alone on a sentence and it can't get any meaningful point across, then it would be a sentence fragment. So it's pretty rare that they're going to have a verb and a subject and be a sentence fragment, but it can happen. And the way to check that is to check if it can stand alone as a sentence, right? So subject and a verb. And, right, this is important, and it has meaning, right? And it has meaning. So it means that there's a clear idea behind it. If there's no clear idea behind it and you need to borrow from another sentence to give it meaning, then that would be a sentence fragment, right? So, and it has meaning. All right, so now we've got modifiers. So modifiers, they're going to modify your subjects and other words to give them more description, right? So modifiers, they have to be placed directly next to what they're going to modify. So I would recommend putting these 3 lines down in your notes. So we have modifiers, they modify subjects and other words to give a more complete description, more accurate description. And they have to be placed directly next to what they modify. That's the big idea here, is if you have a modifier, a modifying phrase, it has to be directly next to what it's going to modify. So if it's an introductory modifying phrase, it has to have a comma after it if it's introductory. So for example, if we had the world's brightest mathematician, that's an introductory modifying phrase. We're modifying who Jim Simons is. For those of you who don't know Jim Simons, he's a genius investor, absolute mastermind, brilliant mathematician, probably a great guy. Never met him. I hope to. But either way, the world's brightest mathematician, that's our introductory modifying clause, right? So we're going to take this, the world's brightest mathematician, that's an introductory modifier. We have to have this comma after it. Next, we have to make sure we have our person we're modifying after that introductory modifying clause, right? So this modifier is going to start us off, and that modifier has to then be directly next to what it's modifying, which is Jim Simons. So we need to make sure we have that comma after it if it's introductory, or we can have commas on both sides of it if it is non-essential, which means we can take it out and still have a complete sentence and a complete idea, and it's in the middle of a sentence. So I'll go ahead and find an example of that. Let's say we had this example right here. We have Jim Simons, comma, because we have to use that comma, the world's brightest mathematician is a genius. So our modifier here is the world's brightest mathematician because it's modifying who Jim Simons is. And we see that it's non-essential because we could take it out and still have a complete sentence. So if we took it out, we would have Jim Simons is a genius. That has a subject, Jim Simons, and a verb is. So that is a non-essential modifier, which means we have to offset it with commas because it's put in the middle of that sentence. So it would be incorrect if we said Jim Simons, that's our subject, is a genius, comma, the world's brightest mathematician, because what we see here is we're breaking our rule because we're not placing it directly next to what it's modifying. We have our modifier, put a big M in highlighter because I don't want to switch to my pen right now. So our modifier is the world's brightest mathematician, and we see our subject that it's modifying is Jim Simons. We see that there's a space between them. I'm going to put this arrow here for that space. We see that it's not directly next to each other. The modifier has to be directly next to what it's modifying. So that would be incorrect, right? If we're going to fix it, we would say Jim Simons, comma, the world's brightest mathematician, comma, is a genius, or we could do the world's brightest mathematician, comma, Jim Simons is a genius. So that's the SAT writing section for today. The tips and tricks, kind of trying to teach you the basics right now. We'll start worrying about pacing later on after you've learned more of the material. Right now, it's really just making sure you have some of the basics down. It can seem like it's really a basic level of understanding for a lot of you, or maybe this is difficult, but if it seems basic, just understand we're going to get into more difficult things later, and I'll start showing you more insights into practice tests, how you can look for patterns, how you can look for setups to really improve your score, and you're really going to start to see the big jumps. If you already know the material, you're going to start to see the big jumps later on when I start getting into examples and I can show you how you can save time and things like that. So if it seems basic right now, just understand it's important that you're accurate to begin with. So this is kind of making sure that everyone has that accuracy before we move on into things such as setups, where we can cut time off by finding the right answer quicker, using process of elimination more. So just be patient. If this seems easy, it's going to get into some more difficult stuff as we go on, but we have to make sure we understand the basics and can be accurate with our answer choices in the beginning. So thanks for watching. Make sure to subscribe, like, and share. Day 3 will be uploaded tomorrow. Make sure if you want to donate, these videos take a lot of time. I'd really appreciate it. The donation link will be in the description when it's live. So if any other links as well as private SAT tutoring, academic consulting will be linked in the description as well if that's available. So thanks for watching and make sure to have a great day.